Welcome everyone. In this video, we're going to continue solving the sample final. So in the last two videos, I went over 10 problems. The first one was 5, the second one was 5. Let's do some more in this video. They're all solved, but let me kind of explain them to you how they work. So let's start from number 11. Please check the last two videos, and those I stopped at number 10. And it's to number 11. So number 11 says find the Laplace inverse of s ln of s minus 3 over s plus 1. Now to find that directly is very difficult. So what we're going to do, we're going to use this property. So the property test says that Laplace of f of t is f of s, then for any positive integer n, Laplace of t to the power of n f of t is -1 to the power of n times the nth derivative of f of s. So if we take the inverse of both sides, so we can say t to the power of n f of t is the Laplace inverse of -1 to the power of n, the nth derivative of f of s. So why do we do that? Let's first substitute. In this case, if we take n equals to 1, because we can just take the first derivative. So the way you can write that again, you can say t to the power of 1 f of t equals the Laplace inverse of -1 to the power of 1, the first derivative of f of s. And let's go ahead and do that. So if you isolate f of t, you get -1 over t Laplace inverse of the derivative of that function. Now in this case, ln s minus 3 over s plus 1, you better write it as ln s minus 3 minus ln s plus 1. You use the properties of ln, so you can subtract them. We do that because the derivative is much easier to take. I'm sure you all know that by now. So you get -1 over t Laplace inverse of the derivative of ln s minus 3 is 1 over s minus 3, and the derivative of ln s plus 1 is just 1 over s plus 1. And you have your -1 over t here. The Laplace, the function for the Laplace of 1 over s minus 3 is just e to the power of 3t. Please know those functions. And for 1 over s plus 1 is e to the -t. So make sure to go over the simple Laplaces and the inverses also. Number 12, y of t equals to cosine t, and the integral from 0 to t y of tau cosine t minus tau d tau, and you know that y of 0 equals to 1. So we are going to use the convolution formula. In this case, make sure to check the lecture on that. And we know that the Laplace of f times g is just f, the Laplace of f times the Laplace of g, well, is f of s times g of s. Now let's set this up. Y prime of t, again, you use this property. L of the Laplace of f of t equals to f of s, then the Laplace of f prime of t is s times f of s minus f of 0. And again, the second derivative, we have it here. Make sure to know this because it's used a lot to solve to differential equations. So now let's go ahead and see how we can write. So y prime of t, by using this property, can be written as s times y of s minus f y of 0, and that's what I did here, equals to, again, the Laplace of cosine t is s divided by s squared plus 1. Make sure to check the lecture. And if you use the integral differential equation, then you know that instead of this, you can just write f of s times g of s, but f of s is y of s, and the integral for cosine, you're going to get cosine t, and then that's going to be s squared divided by s squared plus 1. Now we know y of 0 is 1, and our goal here is to solve, to isolate y of s and use the inverse so you can find the function. So you just use some algebra. So you have take all the terms with y of s to one side. So you take that here and change the sign, or basically subtract y of s of s squared over s squared plus 1 and add 1 to both sides. Then however way you want to isolate y of s is your choice. I took the LCD on this side, so it's s squared, s times s squared plus 1 minus s divided by s squared plus 1, and the LCD on this side, so it's 1 times s squared plus 1, and you multiply both sides by the reciprocal of that function to isolate y of s. S squared plus 1, they cancel, and here if you simplify the denominator, you're just left with s cubed. So basically this is your final answer. Separate, so the term, so you get s squared divided by s cubed, which is just 1 over s over s cubed, which is 1 over s squared, and 1 over s cubed, which is 1 over s cubed. Laplace, the function for that is 1, pretty straightforward. For 1 over s squared, you get t, and here you need a t because 2 over s cubed is going to give you t squared. So you multiply the top by 2 and you divide, multiply the bottom by 2 actually. So it's 1/2 times 2 over s cubed, so you can get that, and that's the final answer. Next one is a system, number 13. So let's go ahead and work on this one. So this is using, it says solve the system using Laplace transform. So here the second derivative with respect to t plus x minus y equals to 0, and the second derivative with respect to t minus y minus x equals to 0, and you are given all these conditions. So again, we use the same thing here. So if you go to the end of this, the solution, I put all the properties, and I will that up for you. And so basically what we're using is derivatives of transforms. So we have that one here, and for the second derivative too. So let me go back to the problem. So we can write this as x double prime of x plus x minus y double prime, x double prime plus x minus y equals to 0, y double prime plus y minus x equals to 0. So, but how can we write x double prime? Is just s squared times x of s minus s times x of 0 minus x of 0. So, and that's plus x, which is x of s, minus y, which is y of s. Y double prime can be written as s squared times y of s plus s times y of 0 minus y prime of 0, and that's plus y of s, and this was x prime of 0, plus y of s, which is right here, minus x of s is equals to 0. So we know from the conditions these are 0. So what we're left with, so x prime of 0 is negative 2. So here we get plus 2, and you have x of s minus y of s equals to 0. And we know that y prime of 0 from here, it's 1. So you substitute. And basically, if you do that, you're just left with x of s and y of s. And that's a simple system to solve. You can multiply the top. First, simplify, take the 2 to the other side, multiply the top by s squared plus 1. And if you do that, why do you do that? Because you know we have an s squared plus 1 here, and that's minus. So we want to eliminate y of s. And if you do that, So the first term is just s squared plus 1 times s squared plus s squared plus 1 times x of s, and negative 2 times s squared plus 1. And here you have negative x of s, and then s squared plus 1 times y of s plus 1. If you add, these are going to cancel, and what you get is s squared plus 1 minus 1 from here. That's minus 1. And you factor out x of s, and on the right side you left it 1 minus 2 times s squared plus 1. And again, what you want to do here is isolate x of s. So, and again, this parenthesis is right here. So you can expand that. You get s to the 4 power plus 2s squared plus 1. Then you have the minus 1. So this cancel. So, and if you want to isolate x of s, you just divide both sides by that. So you get x of s is negative 2s squared minus 1 over s to the 4 power plus 2s squared. And here, of course, you have to do partial fraction decomposition. Again, you can use technology, or if you want to write this, I just did it here for you, so you can see that can be written as factor out the denominator. You can write a over s plus b over s squared plus cs plus d over s squared plus 2. And I try to do this fast. If you set s equals to 0, then these two terms cancel, and that's 0, so you get 2b equals to negative 1. So right away you can get b. And just by inspection, what you can see here, you can check the powers of s squared. So the powers of s squared is just b times s squared. So this is going to give you 2as cubed and 2as squared. But then the only coefficients of s squared is going to be b and d. But you have b, which is negative 1/2. So you can say negative 1/2 s squared plus ds squared equals to negative 2s squared. Basically, if you take these out, then you get negative 1/2 plus d equals to negative 2. Solve for d, you get negative 3 over 2. And if you look at a, here you have the only number that has s is 2. If you multiply, you get as times 2 is 2as, and that's the only one that has s. So 2as equals to, on this side you don't have any s, equals to 0. So you know a will be 0, and you know that the powers of cube you have here, as times s squared is as cubed, and the s times cs is as cubed, and these are the only ones that have cubed. So you know a plus c equals 2. There is no cubed on this side, 0. So a equals to negative c. Basically, c will be 0 also. So if you write this again, so you're going to get b was negative 1/2, negative 1 over 2, 1 over s squared. And that was negative 3 over 2 times 1 over s squared plus 2. However, to write the transform, this is 2, so we need s square root of 2. So you multiply top and bottom by square root of 2. And if you want to find the function, so this is pretty straightforward. It's negative 1 over 2 t, and this one is negative 3 over 2 times square root of 2. And you know this one is sine square root of 2 times t. Now, same way you can eliminate x of t and solve y of t. It works the same way. And if you do that, or you can isolate, taking the second derivative of that. So if you do that, then your y will be negative 1 over 2t plus 3 over 2 square root of 2 sine square root of t. So please try to finish that yourself. I think I'm going to stop here for this one. I will make another video on the last two, probably a little bit longer, but I do have an extra problem here which will help you. Thank you for watching again, and I'll see you in my next video. Have a good one, everyone.